Hello everyone, I'm going to talk about the law of diminishing marginal returns in agriculture. Before explaining diminishing marginal returns through an example, I would like to highlight why it is important in agricultural development in developing countries and which factors need to be realized for it. The principle of diminishing physical and economic returns is one of the critical issues to agricultural production economics. We cannot identify the main problem of the agriculture by ignoring it in developing countries. Although almost all developing countries aim to increase the average yield, not many of them succeed it due to the different production factors. Wilcox states in 1930s that the law of diminishing increments of yield is characteristic of extensive farming where land is abundant and the other growth factors as water, fertilizer, labor, etc. are relatively scarce. Let me firstly start with definitions made by two well-known economists. One of them, Marshall, defines diminishing returns as an increase in capital and labor applied in the cultivation of land causes in general less than proportionate increase in the amount of produce raised, unless it happens to coincide with the improvements in the arts of agriculture. The other one, Earl, had indicates that diminishing productivity of the variable factor exists when each additional unit of input adds less to total output than the previous unit. It is simply stated that marginal increase to productivity will eventually decline when more of a single input is applied. Why the law of diminishing returns operates in agriculture? Firstly, we are seeing that excessive dependence on weather in agricultural sector. The second one, there is a limited scope for mechanization. And the third one, limited scope for division of labor. The fourth one, agriculture uses larger proportion of land resource. The fifth one, soil gets exhausted due to the continuous cultivation. And the last but not least, cultivation is extended to inferior lands. The law of diminishing returns fails to operate under certain stations. They are called limitations of the law. And when we look at the limitations, we see firstly improved methods of cultivation, and the second one, new soils, and the third one, insufficient capital. And when we have these factors, and we cannot say that diminishing marginal returns can be operated. If we illustrate it through an example, it is assumed that we have a farmer producing corn in a limited land under imperfect market conditions. So our assumptions in this example could be based on decreasing fertility of land, less chances of divisions of labor, lack of entrepreneurship capability, resistance to innovations such as use of new variety of seeds, less use of machines, etc. In economic sense, the rational farmer would like to maximize his profits. he has experience from previous years that he can increase the total output of corn by applying more amount of fertilizer this year. If we apply this case to the level of diminishing marginal returns, we increase the amount of fertilizer by keeping the other inputs constant in this farm unit. This table shows factor-product relationship. The farmer is assumed to increase units of fertilizer by 1 unit at each time in order to maximize his profits, while the other factors such as units of land and units of labor are kept constant as indicated in the table. Now we are given the total product of maize as tons. Firstly, we need to find average product of fertilizer by applying the formula total product of maize tons divided by units of fertilizer. The first one is 0.25 divided by 1 equal 0.25. The second one is 1 divided by 2 equal 0.5. The third one is 1.8 divided by 3 equal 0.6. Now we need to find marginal product of fertilizer by applying the formula delta total product of maize tons divided by units of fertilizer as delta. First equation will be 0.25 minus 0 divided by 1 minus 0 equal 0.25. The second equation will be 1 minus 0.25 divided by 2 minus 1 equal 0.75. And the third one is 1.8 minus 1 divided by 3 minus 2 equal 0.8. Now we are seeing total product curve in a graph. 3 stages can be seen in this graph. At stage 1, total product will increase for a time and at an increasing absolute rate and then at a decreasing absolute rate, but always as a percentage rate greater than the rate of increase of the variable factor, until finally a point is reached at which the rate of increase output will exactly equal the rate of increase of inputs of the variable factor. The total physical output will continue to increase at stage 2, but at a decreasing absolute rate and at a percentage rate always less than that of the variable factor, until a point is reached where maximum output is secured. And at stage 3, total physical output will decrease, possibly at an increasing absolute rate for a time, but probably at a decreasing rate through most of this phase, until finally a point is reached at which output is reduced to 0. Our second graph shows average product of fertilizer and marginal product of fertilizer curves. When we analyze the relationship between marginal and average product as shown in graph, when marginal product is more than average product increases. When marginal product is equal with the average product is maximum. When marginal product is less than average product, we say that average product decreases. Lastly, I would like to tell about the relationship total product and marginal product. In this graph, when total product is increasing, the marginal product is positive. When total product remains constant, the marginal product is 0. When total product decreases, marginal product is negative. As long as marginal product increases, the total product increases at increasing rate. When the marginal product remains constant, the total product increases at constant rate. When the marginal product declines, the total product increases at decreasing rate. When marginal product is zero, the total product is maximum. When marginal product is less than zero, negative, total physical product declines at an increasing rate.